Welcome to solverfy.
Okay, we have the following molecule. I'm going to redraw that chlorine to be a little more clear. Okay, and in this molecule we have three stereocenters. We have A, we have B, and we have C. And the question is, what are the stereochemical designations for stereocenters A, B, and C? So one thing I like to do that can help is to add any implied hydrogens, right? We know carbon has 4 bonds, so if there's only 3 shown, there must be a bond to hydrogen. So there's one there, there's one here, and there is one here on a wedge. Now let's begin with carbon A. First thing we need to do is assign priority. Chlorine is the highest priority. Remember, we're using the Kohn-Ingold-Prelog rules, CIP. Then we've got carbon and carbon. Those are for the moment tied, and hydrogen, which is going to be the lowest priority substituent. So let's take a look at these carbons, right? This carbon is attached to 3 hydrogens. So we write down what is attached to from highest to lowest priority. All 3 substituents have the same priority, so we just write them in order. And now we look at this carbon and what it is attached to from highest to lowest priority. That would be oxygen, carbon, and hydrogen. And we compare the highest to the highest, that is oxygen to hydrogen, and therefore this carbon with the oxygen attached will win. Okay, so then we know that this carbon is the second highest priority. There's 3 and there's 4. We connect 1 to 2 to 3, and we get counterclockwise. Now, counterclockwise, when the lowest priority substituent is in back, lowest in back corresponds to S. Clockwise corresponds to R. And then when the lowest is not in the back, counterclockwise corresponds to R, and clockwise corresponds to S. Okay, so we've got that carbon taken care of. A is S. Let's look at B. Now, B has a clear winner for the highest priority substituent, that's the oxygen. And as per usual, hydrogen is going to be the lowest, but we've got 2 carbons to compare. We've got this carbon and this carbon, right? So they're tied, carbon, carbon. Let's look at what they're attached to. For this one, we have chlorine, carbon, and hydrogen. And for this one, we have carbon, hydrogen, hydrogen. And if we compare the highest priority from each group, that's chlorine versus carbon, chlorine wins. Therefore, the carbon with chlorine attached wins. So in terms of priority, this becomes 2, and this becomes 3. We connect 1 to 2 to 3. And we get that this is clockwise with the lowest priority substituent in the back, which we see here corresponds to R. So B is R. Okay, final carbon. Now we've got a carbon, a carbon, a carbon, and a hydrogen attached. So let's put 4 on the hydrogen. We can tell that that is the lowest priority substituent. But then we look at our carbon. Okay, we've got 3 hydrogens attached. Hydrogen, hydrogen, hydrogen. Hydrogen, 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 and each of these are methyl groups, right? And in order to have a stereocenter, you must have 4 unique substituents. That is not the case for the stereocenter in quotation C. This is in fact not a stereocenter. So C is none, right? And if you're not seeing that, just basically know that this is CH3, right? and so is this, right? So we have two identical groups attached to carbon C, which means it by definition cannot be a stereocenter.